Welcome, everybody. Thank you so much for joining us today. Um, Welcome to our very first webinar of 2025. And today we're starting with what is the right choice of colour temperature for airport apron lighting. So before we get started, just a little bit of basic webinar protocol for anyone who's maybe not used Zoom before. So you're all muted. So if you've got any questions, please put them into the Q&A box or the chat box, and we'll try and answer them as we go along. And we've also got some time allotted at the end to answer questions. After the end of the webinar, I'll send out an email with a link to the recording so you can rewatch it or share it with any of your colleagues who this may be useful to. And any resources that we mentioned during the session as well, we'll put a link to those in there. And once we exit the webinar, there'll be a very short survey that will pop up that we'd just love to know how you think we've done today and any topics that you'd like us to cover in the future. So first we'll get started with some introductions. I'll introduce you to our wonderful presenters that we've got here today, a little bit about Midstream Lighting for those of you who don't know us, and then we'll go into the main presentation where we're going to answer questions like what is correlated colour temperature, where to use different CCTs in airports, CCT's role in safety and security, and the efficiency of cooler CCTs. And at the end, we've got 10 minutes for questions. So first off, my name's Sophie and I'm Head of Marketing here at Midstream Lighting. I'm pleased to be your host, and I'm joined today by Mr. Yuli Grigg, co-founder of Midstream Lighting and our commercial director. And Yuli's been working on airport apron lighting projects for the last 15 years and has loads of experience in that area. And Natasha Collins, who's been with us for nearly 2 years now, who works with all of our aviation customers, and she looks after our partners. So Midstream Lighting, we are a LED solutions provider, and we've been doing this since 2010, so 15 years. And in that time, we've done hundreds of projects, and our products are over 150 airports globally. And we are specialists, not generalists. And by that, I mean we only make products and solutions for our sectors. So aviation, obviously being one of them, maritime, sports, and the military sectors. And we don't just sell products, we offer a full turnkey solution and we offer services along with that. So at the beginning of your project, we've probably done a lighting design. We obviously manufacture those products, deliver them, install them. We can do some research around rebates and incentives. We offer consulting and finance. And why we're here today is that we also offer training and education for our customers, because we like to share our knowledge and make sure that our customers are able to make the best decisions when it comes to their lighting projects. So before we get started, we'd just like to know a little bit about you and what you know about correlated colour temperature, or CCT. So in a moment, a box is going to pop up on your screen, and we'd just like you to select one of the answers. Apologies, there is a rogue question in there, rogue answer, sorry, I should say. So if you know nothing about CCT, that's perfect. We're going to teach you something today. For those of you who know a little bit, again, hopefully there's something we can tell you that you don't already know. And for those of you that already know a lot, perfect. We're glad to have you anyway. So just going to give you another 20 seconds because I can see we've already got loads of votes coming in. And we'll see where we get to. Okay, perfect. So as we suspected, over 60% of you don't really know a lot about CCT, and that's fine, because what we hope by the end of this is that you'll all say that you know a lot. Okay. So now I'm going to hand over to Natasha, who's going to do the main part of the presentation.
Hi, everyone. So first of all, why are we doing a webinar on CCT? I think it's something that we've been increasingly asked about, and it plays a huge role in safety and operational efficiency. So we hope we'll be able to share our experience with you today and share some good practice too. So what is CCT? So CCT stands for correlated color temperature. And it is it describes the hue or the color of a light source, and we measure it in kelvins represented by the K. It plays a crucial role in visibility, safety, and just the overall operational efficiency at airports. So as you can see in the diagram, the lower Kelvin values, such as the 2000 Kelvin and 3000 Kelvin, produce a warm yellowish light. And that's similar. You can compare it to a traditional incandescent bulb, which you might find at home, or a candle light. This we'd call it a warm light. So then moving up the scale to 4000 Kelvin, we get a more neutral light, and this can be compared to daylight. And then as we go beyond 4000 and we get to 5000 Kelvin, this produces a much cooler light with a bluish tone, and yeah, as you can see, it gets bluer as the Kelvins increase. So around 6000 Kelvin would be used for a surgeon's operating room because of the need for the increased visibility. And when we get to around 7000 Kelvin, that would be a computer screen. As you can see, the blue, as it gets higher in Kelvin, it gets more blue. Yuli, I think you wanted to mention how CCT originated.
Indeed, thanks. I think that what's interesting to remember is that we're talking about temperature here, but actually we're not talking about the heat, we're talking about the color. And the reason for that is that, you know, if you remember or from school, there were 4 types of scales for temperature. There was Celsius, Fahrenheit, and there were 2 others. There was Kelvins, as in Ken, K, and Rankins, the R. And this is just one of the types of ways to measure a temperature. So why are we using a temperature to measure a color? And it all goes back basically to Planck's law, which, if we say it in simple terms, imagine a piece of metal, and when you heat it up, it first starts with a red glow, then it moves to yellow, and the more heat you apply to it, then goes to white and even blue. Imagine, in comparison, like if you look at the sun, it's a very white to yellow glow, but the stars, which are much hotter, are kind of white and blue. So in essence, it's sort of saying that the more heat you put into it, the more white and blue it becomes, and the less is the more orange and red. So higher temperature, higher heat you put onto a metal, the bluer the light, the lower the temperature, the more warm the light is. So higher temperature, cooler light, warmer temperature, lower temperature, but warmer light. So it's a little bit confusing, but that's really the origin. It all goes down to Max Planck, who developed the law on black body radiation. So I think we have to think about why are different color temperatures used in different environments. And let's just go back and think about in our own homes. You know, in the bedroom, we might use a warm, a yellowish kind of light, whereas in the bathrooms or the kitchens, we might use a more cooler light, a more white light. And the reason for that is actually because our bodies react differently to this different color temperature. And it really affects us in the eyes and the brain the most. We have different receptors in our eye, in the retina specifically. There are 3 types of receptors. They're called rods, they're called cones, and they're called something ganglion cells. Now, maybe not everybody here is English is their first language, so maybe in your languages they're called differently, but the rods in the eye are basically responsible for low-level lighting, and they have no perception of color. So the rods are color indifferent. The cones, on the other hand, are basically what gives us the color vision, and they respond particularly well in bright light. So that's kind of the color vision. And the ganglion cells, these are the non-visual responses, right? So these are the ones that basically send the messages to the brains of how to react. And they specifically react to color temperature and more specifically to blue light. So these ganglion cells, the RPRGCs, they react more to the blue light inside the color. And how do they react? Well, they send certain electrical signals to the brain, which then start to generate or release types of hormones. There are, in fact, four main hormones that are affected by this. Melatonin, which is known as the sleep hormone, serotonin, which is kind of the mood regulator. You have cortisol, which is kind of the alertness, and also you have dopamine. I'm just looking at my notes here because it's quite technical now. But the color temperature creates different impacts on the body. So if we just think about the warm light, the 3000 Kelvin, this is what you might find in a bedroom or sort of a lounge in a hotel. This reduces the suppression of melatonin. Melatonin is the sleep hormone. It's the one that allows us to relax at night. So when you have a warm light, this suppression of this melatonin, it allows melatonin to continue generation in the brain and in the body. And so this is good for relaxation. Okay, you can relax with it. It also reduces the production of serotonin, cortisol, and dopamine. So these are the alertness or the mood, the motivation types of hormones. They're reduced. Move across to the 5000 Kelvin and above, then you have the blue peak of light coming out. And so this boosts serotonin, it boosts cortisol, increases dopamine, but reduces melatonin or increases suppression. So actually, what happens is that in 5000 Kelvin above, or where there's a peak of blue light, you basically have difficulty falling asleep. You become more alert, and you become more focused on your tasks. So imagine a situation where you're at home, relaxed, sitting on the sofa or in the hotel lobby, and there is an emergency. It's very difficult to orientate yourself. However, if you are in a high state of alertness and you're focused on the tasks in hand, if there is a situation, you can typically react quickly. So that's really the reason why the level of light is more suitable for the task at hand. Do you want to relax or do you want to be alert? Of course, as you know, and Natasha mentioned, our screens have a high level of blue light in order to generate the clarity of color and for other reasons. And so it's highly recommended to switch off the blue peaks of light after in times of darkness or in the evening. So personally, I set it at 5 p.m. I remove all the blue from my phone, and most phones now do this. It's a setting, and it sort of becomes almost yellowy. But definitely, if you're reading your phone before bed, it's highly recommended not to have the blue lights. The blue light should be reduced so that you can then increase the melatonin and then fall asleep naturally.
So speaking more specifically about CCTs in airports. So if we start the lower end of the scale, so 3000 Kelvin. So typically in airports, we're looking at 3000, 4000, and then we go into 5000 Kelvins. So if we're looking at the lower end of the scale, 3000 Kelvin, as you mentioned, is ideal for relaxation. So if we're thinking about airports, we're looking at lounges and rest areas generally. The warmer tone creates a more comfortable environment, inviting atmosphere, and also helps really reduce stress and promotes a sense of calm. So those areas, like in lounges and passenger lounges and the rest areas, they're ideal. We move up to 4000 Kelvin. This is commonly used in terminal areas, particularly things like gates, security, checkpoints, and border control areas where passengers and staff need to be a bit more alert. The neutral white light maintains good visibility, but while also being comfortable for prolonged exposure too. Then we have 5000 Kelvin. So this is the standard for apron and operational areas. As you can imagine, everybody needs to, whether it be passengers embarking or disembarking, whether it be ground staff, fueling, and baggage, everybody there needs to be alert, and it's crucial for safety and because it's such a high activity zone. Some of you might, at your airport or be working on a project, be asking, what about 5700 Kelvin? So we do see this in airport applications, but we actually more commonly see it in sports lighting. And the reason is that the higher the CCT, it enhances color contrast and also improves visibility on broadcast cameras. So high definition broadcasting and slow motion cameras require a higher Kelvin, because this is more ideal for televised events. So it's not necessarily needed on apron areas, but we do see it at airports and in apron areas.
I think it's also good to talk a little bit about the role of CCT from a safety and security standpoint. Now, we know that the white light, 5,000 Kelvin around, really improves camera performance. And the reason why it does that is that the white light allows for better color fidelity, sharpness, and also contrast. So actually, this is particularly important when cameras are used for facial recognition, so that cameras can have a good detail, and also for airports which want to then keep for a long period of time the imagery. You know, this data is typically compressed, and so you really need to have good quality and sharpness and focus, so that this image is then, when it's used again in the future, it has enough information in there to be able to make decisions about recognition. But it also works for facial recognition of humans. So white light allows humans to recognize facial features better. And so not only is it better for the feeling, better for security and safety, but it also enhances the feeling of safety. When you see somebody and you cannot quite distinguish their facial features, it can create a certain level of stress or fear. Whereas normally, if you can see someone's face, well, that reduces that feeling of fear. Imagine yourself walking down the street and somebody approaches you with a mask covering their face. It doesn't make you feel very good, right? It creates a flight or fight reaction straight away. Whereas if somebody approaches you and their face is open, it's much better. So the same thing here happens. The white light just improves the clarity and the ability to see facial features better. So from a safety and security standpoint, it's important. And then, of course, we get often asked, or some people think about, how do lighting manufacturers create this color temperature, right? What do we do as midstream to make 5,000 or 4,000 or 3,000 or 5,700 even? And the answer actually is we don't do anything about it. We specify from our supply chain the type of LEDs that we need to employ for the purposes of that particular scenario. So if an airport orders a batch of floodlights, then we would order from our suppliers of LEDs like Cree or Nichia or Samsung or Lumileds. We would request them to be, for example, 5,000 Kelvin. But if we were working on a project which was, for example, in sports, it might be 5,700. Or if an airport has a specific requirement for a different color, we would order that too. And actually, that has some impact on lead times, because it depends on what is the more fast moving. But how do those guys, how do they, in fact, make the chip manufacturers make a different color? And the answer is actually by applying something called a phosphor coating. So here is an image. This is not a typical high power LED. This is more something called a chip on board, where you have one phosphor and underneath you have lots of different chips. But in fact, the yellow is the phosphor. And this is what converts the blue light, which is emitted by the LEDs. Most white LED chips actually emit a blue light. And then you apply the phosphor coating on top of it to turn it from blue into actually a white light. And it does that by converting certain peaks of blue into reds and yellows. And then mixed together, it creates ultimately a white light of the type of temperature you're trying to achieve. And you would do that by applying different thickness and different type of phosphorus. And sometimes certain manufacturers even apply multiple phosphors so they can then adjust and have a balance between red, green, and blue components, and then create a typical output of the light overall. So basically, they fine-tune it using this phosphorus application, and that then has a knock-on effect on efficiency, which actually takes us to the next slide. So efficiency, we mentioned this earlier, and I think we have to be clear about it. Cooler, so 5,000 above, are typically more efficient than warmer. There are several reasons for this, actually. The most simple one to understand is the phosphor conversion loss. So when you apply a thick coating of phosphor to make it a more warm light, more yellow, more red, remember we're going from the blue into a white light, so we need to apply more reds and yellows to make it warmer. Then that thickness means that as we convert it, we incur energy losses. And so that reduces overall efficiency. It has to pass through more phosphorus, so you have some losses there. At 5,000 Kelvin, it's closer to this original blue spectrum, so actually have fewer losses. Then there are other things like spectral efficiency in human vision. So humans actually are able to see better, they perceive brightness more with a higher peaks of blue. And therefore, we need to put less energy into it to give a perceived feeling of brightness. So overall, we typically say that between a 3,000 Kelvin and a 5,000 Kelvin, depending on how you're driving the LEDs, there's normally between a 10% variance of efficiency. Remember, we measure efficiency in LEDs with a concept of lumens per watt. So how much power do you have to put in to get the lumens out? And on a lumen per watt basis, you would expect to get 10% lumens less per watt of power in 3,000 Kelvin than you would in 5,000 Kelvin. This has improved, actually. So if we went back 5 or 7 years ago, the difference would have been wider. It would have been about 15 to 16%. So if you think about something like 5,000 to 4,000 would have been in the past about 7 or 8% reduction, and then from 4,000 to 3,000 would have been even more. And then in certain cases where we have to really reduce and take out certain peaks of blue like completely, then we can get a 30 or 40% loss in efficiency too. But those are kind of extreme cases. But what does that even matter to an airport? Well, it matters quite a great deal, because if you employ a large number of luminaires on an airfield, if you're a big airport, one of the, some of the massive ones like, Paris Charles de Gaulle Airport. Hello. So we were just there actually a few days ago, talking to them about actually what is the importance of efficiency compared to color temperature, and they have their own requirements there due to, I think it's municipal codes. But what we were explaining is that if you have an area that you need to have a target lux levels of, for example, 20 or 30 lux, with less efficiency on the luminaires, you need to firstly use more watts, okay, 10 or 15% more watts, which means that already you're using energy more, and so that's an energy loss. And secondly, of course, we convert that additional energy into CO2 equivalent. So we also have a problem with our sustainability goals, because we're using more than we should be. And then remember that, it's not always perfect. If you have a luminaire which is 1,000 watts and there's an array of them, and you just manage to reach 19 lux, then you have to put more luminaires on, and then you will go to 23, 24 lux. So you basically have a little bit too much light and a bit too much energy, but there's no other way to do it, because you've had to then, to get that one extra lux, increase more the output of the, increase more the number of luminaires, because you have less efficiency. If you could only just increase the efficiency, you might not need the extra fixtures. So that's why I think overall it's better to have higher efficiency if you can. Now I think I'm conscious of time, Sophie, because we wanted to try and keep this to within 30 minutes, didn't we?
Yeah, so we've just got one final slide, Natasha.
Yeah, so I'll just conclude what we've been speaking about, and I hope we've been able to shed a bit more light on the reasons why different airports might choose different color temperatures. But so yeah, we would suggest the 5,000 Kelvin, the cool white light, as the best choice for apron lighting due to efficiency, safety, and alertness benefits. But really, overall, I think what the aim is to make sure that the apron areas are safe, because they are critical for airport operations. So this efficiency using 5,000 Kelvin reduces energy costs, as Yuli was just explaining, carbon emissions, and also reduces the number of the required fixtures overall. There are some countries that have different requirements, like Yuli just mentioned with France. They have a 3,000 Kelvin requirement, and in that situation, there's nothing that you can do. But if there is a choice, from our experience, we would choose 5,000 Kelvin. I think, Yuli, there are a couple other places that had requirements too.
Yes, that's right. So some that come to mind straight away are the Canary Islands. So they have a very strict requirement to reduce all blue light from the emission. And that's for the purpose of astrophysics. So they have the telescopes and they are studying space. And so those blue lights really affect the way the telescopes work. So no blue light emissions at all. Florida is another interesting one, because that is for conservation purposes. So they have a lot of breeding of turtles on the beaches, and the turtles get confused by the blue hue of the light, the blue peaks of light. So if you're ever driving through certain parts of Florida, on the street lighting almost feels like some kind of an orange, or blood orange color. It's so red that it feels unusual, but that's again for the turtles. So in whether it's astrophysics or conservation, or it's municipal codes like in France, for historical architectural reasons, then we have to obviously abide by that. But generally, our go-to choice would be 5,000 Kelvin.
Wonderful. Well, thank you very much, Yuli and Natasha. That was really interesting. And we hope that all of you found that interesting as well. So now we're going to move on to questions. I can see some of you are popping them in. If you can, please pop them into the Q&A box. It just makes it easier to find them. But no problem, I have seen the ones in the chat, and we'll try and get to those too. So first up, our first question, can you mix different color temperatures on an apron, and is it visible to the eye? Natasha, do you want to answer that one, please?
Yeah, I can take that one. Actually, we've been asked this a few times, and with the simple answer really is that it's not good practice to mix color temperatures purely because it is visible to the eye. So if you're mixing 4,000 Kelvin and 5,000 Kelvin, there will be a visible difference, with the 4,000 Kelvin being a warmer light and then the 5,000 Kelvin being the more blue light. So we typically say that in one apron area, it's got to be the same color temperature.
Okay, wonderful. Thank you. Our next question, and we've got a few that are similar to this. Does iCal have any requirements for color temperature? Yuli, could you answer that one, please?
Yeah, sure. So actually, iCal doesn't specify anything with respect to color temperature, but it does identify the fact that you need to have the ability to recognize colors well, because you have certain operations on the apron. You have certain markings on the apron, the colors of yellow, or it could be red, or people wearing high visibility in yellow. So just it says that there has to be a color which allows for clear recognition. Now, if you go with a very yellow color, that obviously affects the recognition of other yellow colors. And so therefore, typically white light is better for that element of color recognition, and also for alertness. I think that there is no specific requirement anywhere, but from our experience of working with airports over the last 15 years, typically the white light, the 5,000 Kelvin is the best choice for alertness. I certainly wouldn't want people yawning and feeling like it's time for bed when they need to be unloading the luggage. So I think it's just common sense.
Okay, brilliant. Thank you very much. And then along the same effect, can you outline specific requirements for in the UK that refer to CCT? Is it along the same lines as ICAO?
So in the UK, remember that ICAO are recommendations. It's the International Civil Aviation Organization, so they can't mandate anything for each specific country because of sovereignty. But each country will then typically use those rules and convert them into a local regulation. So in the UK, CAP 168 typically was what converts the recommendation of ICAO into regulation in the UK. In Europe, it's the EASA rules. And they basically follow the same things that are written in the ICAO document, which is basically you have to have proper recognition of color, and doesn't really go very much into it. In fact, I think apron floodlighting has the smallest section of the ICAO Annex 14. It's probably like, I don't know, 1.5 pages, and the crux of it is probably written in 2 or 3 paragraphs. It's not a very detailed piece of documentation, and I think it was probably a little bit rushed when they did it. Basically, the answer is it's not written, but it's suggested.
Okay, brilliant. And then again, along the same lines, we've had quite a few questions about this. So how many aprons with 5,000 Kelvin have you installed? Have you noticed? Mainly in the UK is the question, but I guess just generally would be useful.
Well, I think the question would probably be better answered by saying how many have we done which are not 5,000 Kelvin, and I struggle to think really. I mean, we've had a number of requests for 4,000. So 4,000 something we worked on a couple of areas, predominantly in Europe, but mainly UK. It's 5,000. Remember, in the past, when LEDs just came to the market, it was only 5,700 was the only available color temperature. Technology wasn't really able to provide something with 5,000 or 4,000. As technology improved, efficiencies improved, we now moved into 4,000. There are probably a couple, but it's a handful which are 4,000, and the majority are 5,000.
Brilliant. Thank you very much. We have another question. Does military aviation require any specific color lighting? Is there any requirements for that?
No. Again, military are typically following the civil aviation codes generally. Sometimes they are employing, infrared for operational reasons, but normally, from my experience, military, it's always a bright white light because it is typically a high level of alertness, and they need to really be able to understand the different colors and things that are happening on the apron.
Brilliant. Okay, we've got loads of questions, so we're probably just going to get through 2 or 3 more. So our next one, does color temperature change over time?
So that's a good question, actually, because it shouldn't change over time, but it does as LEDs degrade. And so where we've seen instances that that heat is really the worst. Heat is the worst killer for LEDs. So in systems, LED systems where heat dissipation isn't well developed or isn't well implemented, smaller type of heat sink radiators or too much power for the size, what happens is the LEDs overheat, and basically they start to degrade, and that's when you have a color shift. So we've seen in some instances where there's been a poor quality lighting fixture installed on an airport. It's gone from white to basically green or blue within a space of a year. It feels like you're kind of walking on the moon. It's such an unusual feeling, but that's because the LEDs have failed, they've color shifted. Normally, in most cases, it should remain the same until it gets to the end of its useful life, and then you could start to have the color shift effect happening again.
Brilliant, thank you. Is there any study relative to worker alertness with different CCTs on airports or other outdoor applications?
Well, we haven't done a full academic research on this, so we don't really know what are the published papers on the subject. I've had a quick look earlier, actually. This is from Richard, is it? Yeah. I've had a look at this previously, and they've said different things. There's some information, actually, atypically, that they did a research on some students in using virtual reality, and they were able to demonstrate that students had a better retention, better memory of the things they were reading in lower lighting conditions. So what we would think inside a typical classroom should be 500 lux. Apparently with 120 or 130 lux, they were having better retention and better memory. However, how is it specifically with CCT on the airport? I'm not familiar with any academic studies, but we haven't done a literary review for this yet.
Okay, fantastic. Our next question, are there any cons on using 5,700 Kelvin compared to 5,000 for the entire apron?
I just think it's too blue. It's just a discomfortable light. So it just feels a little bit like you are under some kind, it's just not very natural. 5,000 is much closer to natural daylight. So 5,700 is just blue, and it feels kind of like a cheap or a cool, unpleasant feeling. So the only cons are the perception, I think.
Yeah, and possibly just to add to that, it could also possibly be that because the majority of airports use 5,000 Kelvin, when having 5,700 will just, it will probably look different to passengers and also to anybody coming in. So it will just probably be a bit different to what passengers are typically used to.
Perception, yeah.
Yeah.
Okay, wonderful. I think we're going to try and squeeze in 2 more questions, then we'll call it a day. Anything we don't get to, obviously, we will follow up in the email. So our next question, hi, do you experience the veiling effect with the weather conditions of 5,000 Kelvin? The tower controller experiences this?
I'm not actually sure what is the veiling effect with weather conditions.
Maybe
Yeah,
this is one we could get Paolo, our technical director, to follow up with.
yeah,
It's probably a bit too technical for us, but definitely we will follow up your question, and we have had one other along those lines as well, and we'll follow up with you directly just to answer that.
yeah, because we need to understand what's meant by weather conditions. If it's about how yellow light versus white light and fog, then actually that's a huge discussion. We have an article on that, which is quite detailed. If it's something else, then we need to get in touch with the person asking and find out more what they're looking for.
Okay, brilliant. And final question, because we've got a minute left. So many really good questions. Thank you, everyone. We've done the UK practices.
Can I just try this one? Is there any
Of course.
system for measuring glare levels? So glare levels, just to quickly answer, needs to be measured with a camera. It's a special camera, and you go at different points on the apron, and then you can do a study. So typically it's done by a consultant, and so, but it is possible.
Okay,
It's
wonderful.
still a little bit, it's a lot of glare is around perception, different levels of glare for different people. But there is a whole webinar that we have on glare, which we can suggest to look at, because that goes really into details about glare.
Yeah, brilliant. I will put a link to that in the recording as well, for the gentleman who's asked that question, So it might be useful for you. And for anyone else, we've got loads of stuff on our Knowledge Hub, our previous webinars where we've answered different questions. And we may even do another one in the future with the series we're doing this year. So I'm going to call it, and that's all we've got time for today. I know we haven't got round to answering everyone's questions, and we will follow up in an email just answering those. And we may even do a webinar on some of those questions as well. So thank you very much for being here today. It's been really useful for me. I've learned quite a lot, and I hope you guys at home have as well. So obviously I've mentioned the webinars. Our next one up is around the maintenance factor, and that's towards the end of February. I will include a link to that in the follow-up email. So for anyone who'd like to register, you can do so. And if anyone has any questions that they didn't have a chance to answer, you can of course follow up with Natasha or Yuli. Their contact details are on the screen now. And again, just a big thank you to everyone, and thank you Natasha and Yuli for joining us today. Thank you, and hopefully we'll see you soon.